Hello everyone and welcome to our today's class. It is our fourth and last lesson on the topic cells and simple circuits. So as usual, let me commence by giving you the quote of the day, which states that if there was no darkness, no one would appreciate the importance of light. And also, failure is enough evidence that at least you are trying. So we'll discuss that quote at the end of our class today. So today, remember in our previous class, we did look at what we call the chemical cells. So we said that chemical cells produce an electromotive force as a result of chemical reactions. Then we said that there are two main categories or two main types of chemical cells. We said one is the primary cells and two is the secondary cells. So in our previous class, we discussed about the primary cells. So today we are discussing about the secondary cells. But let us remind ourselves of what was the difference between the primary and the secondary cells. So we did say that primary cells are those chemical cells that cannot be renewed once their chemicals are exhausted, whereas secondary cells are those chemical cells that can be renewed by recharging. Secondary cells are the chemical cells that can be renewed by recharging. So today we are looking at secondary cells. So first of all, we look at how to charge and discharge a simple secondary cell. So a simple secondary cell consists of two plates. One, we have the lead plate, then we also have the lead plate also on the other side. So of course, one of the plates is our anode, that is the positively charged, that is this plate here. Then the other plate, of course, is the cathode, or which is negatively charged. Then of course we also need an electrolyte. In this case we are using dilute sulfuric acid. Now, so to charge or discharge a simple secondary cell, you need some apparatus. So the apparatus required in this experiment is one, you need two clean lead plates. This is what we are calling our lead plates. We have one here, then another one here. So we need two clean lead plates. We also need a beaker containing dilute sulfuric acid. So this is our beaker in this case. Of course, it is containing our dilute sulfuric acid. Then we also need a charging battery. You need a charging battery. So this is our charging battery. Then you also need a zero-centered ammeter. This is our zero-centered ammeter. Sometimes you can also use what we call a galvanometer, of course with a pointer. Then we need, of course, connecting wires. These are our connecting wires. Then we need a variable resistor, or also we can also use a rheostat. So this is our variable resistor. Then we also need two switches. That is switch 1, so switch S1 and switch S2. Then after that, of course, the procedure involved now is one, you set up the apparatus as shown here. So you set up the apparatus as shown in this particular diagram. Then you close switch S1. You close switch S1, of course, with the switch S2 open. So close switch S1 and observe the changes on the plates. That is, if there are any changes. So you close switch 1, of course, with switch 2 open. Then you observe if there is any changes on these two plates or on these two lead plates. Then you note how the ammeter reading varies with time and the direction of the pointer with respect to the zero mark. So after closing switch S, you observe our ammeter here. Actually, if there is any deflection that is detected. So the observation expected in this particular experiment is that when switch S1 is closed and S2 is open, that is when we close this particular switch, or when we complete this circuit of S1, when switch S2 is still open, that is, the cell is charging. So when we close S1, remember, current is flowing, or electrons are flowing through this particular cell here. So our cell is actually charging. So when S1 is closed while S2 is open, the cell is charging. Then the positive plate, which is our anode, so this is what we are calling our positive plate. It is connected to the lead plate, which is our anode in this case, or the positive charge or the positive electrode. So the positive plate into bracket the anode turns black brown, while the negative, which is the cathode, so it is observed that the positive plate or the anode here, this plate here, it turns dark brown, while the negative plate, which is our anode, in our cathode in this case, this is what we are calling our cathode, the negative plate, of course, because it is connected to the negative terminal of our battery in this particular case. So when S1 is closed, actually that is when the battery is charging, the positive plate or the anode turns dark brown. We'll see why. While the negative terminal, which is the cathode plate, it remains metallic gray. So the negative terminal remains metallic gray, or it maintains its color, whereas the positive terminal is observed to turn dark brown. So we will see why. At the same time, the ammeter, the gas bubbles form on the two plates. We'll see what is these gas bubbles and where are they coming from, but probably it will be the hydrogen gases. So the gas bubbles forms on the two plates, that is both on the negative plate or the lead plate here, and the positive plate, which is the anode or the lead plate here. So gas bubbles are observed to form on the two plates. Then the ammeter deflects away from the zero mark. So the ammeter deflects away from the zero mark, indicating that there is flow of charges or there is current actually passing through. Then it is also observed that the deflection decreases with time. So with time the deflection decreases. So it is because of the defects that such a cell will actually suffer. However, when switch S1 is opened and S2 is closed, now remember in our first case we had closed S1 and opened S2, that is during charging. Now we are opening switch S2 but closing, we are opening switch S1 and closing switch S2. So of course this is the process of discharging now. So when switch S1 is open and S2 is closed, the cell is being discharged. So when we open this one and close this S2, the cell is now discharging, that is passing current to an external circuit, because the current passes through this. So current is passing through an external circuit when S2 is actually closed, while S1 is open. So that is the process of discharging. So the ammeter, it is observed that when S2 is closed and S1 is open, the ammeter deflects in the opposite direction with respect to the direction during charging. That is, if when S1 was closed, that is during the process of charging, if the ammeter was deflecting to the right, then when S2 is closed and S1 is open, the ammeter is observed to deflect to the left. That is, it deflects in the direction opposite to that of charging. So the ammeter deflects in the opposite direction with respect to the direction during charging. Then again during discharging, that is when S2 is closed, the dark brown color on the positive plate turns to gray and gas bubbles are seen on the plates. So actually remember we said that during charging, the one of the plates, that is the positive plate, turns dark brown. Now during discharging, the dark brown color on the positive plates, now that particular dark brown color turns into gray. We will see why it turns into gray color. Again, also the gas bubbles are seen on the two plates. The gas bubbles are seen on the two plates. Now let's explain these observations. So during charging, that is when S1 is closed while S2 is open, that is when this gap is actually closed, that is during charging, sulfuric acid is electrolyzed. To electrolyze sulfuric acid means it actually dissociates or breaks down to provide the hydrogen gas and also the oxygen. So during charging, the dilute sulfuric acid is electrolyzed, giving off oxygen at the anode and hydrogen at the cathode. Now the question is, why does oxygen why does hydrogen form at the cathode whereas oxygen form at the anode? So the oxygen forms at the anode because, remember, oxygen atoms are negatively charged. It is usually 2 negative. So if it is negatively charged, it will always form on the positive terminal, Why? Because remember, unlike charges will always attract each other. So the oxygen atoms which are negatively charged, they are attracted to the positive terminal, that is the lead plate, because unlike charges will always attract each other. So during charging, sulfuric acid is electrolyzed, giving off oxygen at the anode and hydrogen at the cathode. Remember, hydrogen is usually H plus, meaning it is positively charged, so it will always be attracted on the negative terminal or on the negative plate. So the oxygen reacts with the lead to give lead 4 oxide. So the oxygen that actually came to the positive terminal, it reacts with the positive terminal, that is with the lead, to form lead 4 oxide. So the oxygen reacts with the lead plate that is on the positive terminal to form lead 4 oxide, which is deposited at the anode. So that lead 4 oxide is actually deposited at the anode. So that deposition, that is what we were calling, it turns into dark brown. So the anode turns into dark brown. So that dark brown color is the lead 4 oxide that has actually formed as a result of reaction between the lead plate and the oxygen, which actually is attracted to the positive terminal, which is the lead plate. So if you are asked to state what is this dark brown color emanating from, so it is because of the lead 4 oxide. Remember, lead 4 oxide is usually dark brown in color, so it forms on the positive terminal, which is deposited at the anode. Then hydrogen gas formed on the cathode. Remember, the hydrogen gas that has dissociated from the dilute sulfuric acid is attracted to the negative terminal. This is what we are calling our negative terminal. So our lead plate here is negative. So the hydrogen gas, because it is positively charged, because the hydrogen ions are positively charged, they get attracted to the negative terminal, therefore forming hydrogen gas. So the hydrogen gas formed at the cathode, it has no effect. Then the flow of current through the ammeter decreases with time, because the cell starts supplying current in the opposite direction to the charging current. So during discharging, actually the current moves in the reverse direction, therefore the cell actually discharged, therefore the ammeter also deflects in the opposite direction. So the flow of current through the ammeter decreases with time, because the cell starts supplying current in the opposite direction to that of the charging current. That is during the charging process. Now in discharging, during discharging, remember, discharging is when we have closed S2 and we have open switch S1. So during discharging, the current flows in the direction opposite to that when charging. The current flows in opposite direction to that when charging. Oxygen gas bubbles form at the cathode, while hydrogen gas forms at the anode. So the dark brown color on the positive plate changes to actually gray. It changes to gray. So remember, during the process of charging or discharging lead acid accumulators, or simply a simple cell, there is production of hydrogen gas and also oxygen gas. So remember, when these two gases react, when hydrogen gas and oxygen gas, they are highly flammable. That's why it is not advised to light a cigarette near a charging battery, because during that process, oxygen and hydrogen gases are produced which are highly flammable. Highly flammable means they could easily catch a flame, they could easily actually burn, which could be disastrous to other components near that charging accumulator. Then we look at what we call the lead acid accumulator now. So remember, a lead acid accumulator, this is just a type of a secondary cell. So we have two main types of secondary cells. We have what we call lead acid accumulator and what we call an alkaline accumulator. So remember, secondary cells, these are what we are saying that these are cells that can actually be recharged. They can be recharged, or they can store actually charges. So for lead acid accumulator, this represents the reactions that take place within the lead acid accumulator. So the positive terminal of the lead acid accumulator is actually the lead 4 oxide. Remember the oxygen that came and reacted with lead to form the lead 4 oxide, which is the anode or the positive terminal. Then the negative terminal is simply the lead metal, or simply our cathode. So a lead acid accumulator is the most reliable, long lasting and cost effective secondary cell. It is the most reliable, long lasting and cost effective secondary cell. So we'll see why. But one of the reasons is because lead acid accumulator does not suffer defects such as polarization and local action. So somebody can ask you to give advantage of a lead acid accumulator over a dry cell. You can be asked to give an advantage of lead acid accumulator over a dry cell or any other primary cell. So the advantage of a lead acid accumulator over a dry cell or over primary cells is that it does not suffer defects such as polarization and local action. That's why it is the most reliable, long lasting and even cost effective of the secondary cells. Now a lead acid accumulator has it is a 12 volt lead acid accumulator, has 6 cells connected in series. So a lead acid accumulator simply has 6 cells which are connected in series. So if we are talking of 6 cells, each having maybe a voltage of maybe 1.5, so you take 1.5, you multiply by 6. If you take 1.5, you multiply by 6, so you will actually get around 12. You get around 12 volts. So a lead acid accumulator is a 12 volt lead acid accumulator. It has 6 cells connected in series. Now each cell has several plates made in form of a lattice grid. So the positive plates, that is carrying the lead 4 oxide, and the negative plates having spongy lead. So the lead plates are very close to one another and are prevented from getting into contact. Remember, when they get into contact, that is what we call short circuiting. That is what we call short circuiting. So the plates are very close to one another and are prevented from getting into contact, that is short circuiting, by having insulating sheets separating them. Then the surface area and the number of plates in a given cell determine the current flowing capacity of the battery. Then the charge, or simply the electrical energy stored, is directly proportional to the surface area of the plates. So the larger the plates, the larger the surface area of the plates of the lead acid accumulator, the more the electrical charge it will actually store, the more the electrical charge that particular lead acid accumulator will store. Then another question can be asked here. We are saying that a lead acid accumulator consists of 6 cells arranged in series. So somebody can ask you, give a reason why 6 dry cells arranged in series give the advantage of using a lead acid accumulator over 6 dry cells arranged in series. So when cells are in a lead acid accumulator that is arranged in 6 cells arranged in a series in a lead acid accumulator, when the cells are arranged in a lead acid accumulator, they offer less resistance to the flow of current. Whereas when you take dry cells, arrange them in a series, that is exactly the same number of dry cells, that is 6 of them, they offer high electrical resistance. Therefore, a lead acid accumulator, that is when cells are arranged in lead acid accumulator, they can offer charges for a long time, or they can supply current for a long time. Why? Because they offer low resistance. Whereas when the cells are arranged in when dry cells are arranged in series, they offer very high electrical resistance. So again, we are saying that the surface area and the number of plates in a given lead acid accumulator cell determine the current carrying capacity of that particular battery. So the charge, or the electrical energy stored in is directly proportional to the surface area of the plates. Now the container used in constructing a lead acid accumulator must be mechanically strong, that is highly acid proof and with insulating properties. Insulating properties so that it prevents the flow of charges to or from the earth, or to prevent earthing. then the electrolyte is a solution of about 64% water with a relative density of around 1 and about 36% sulfuric acid with a relative density of around 1.84. So when the accumulator is discharging or giving away electrical energy, the sulfuric acid dissociates or breaks down into hydrogen ions and the sulfate ions. So here we are actually showing the lead acid accumulator. The anode, we have said it is lead 4 oxide, while the cathode is actually the lead metal. So this simply shows how actually the reactions actually take place within a lead acid accumulator. So at the positive plate, this is what we are calling our positive plate, that is the lead 4 oxide. The sulfate ions react with lead to form lead sulfate. So at the anode, that's at the positive terminal, this is the reaction that actually takes place. So at the anode, the lead 4 oxide, this is our lead 4 oxide, it reacts with our electrolyte, which is the sulfuric acid, the dilute sulfuric acid. So when the lead 4 oxide reacts with sulfuric acid, it forms lead 4 oxide, which is a solid plus water. So actually the two oxygens combine with the two hydrogens to form water. So water is actually produced at the lead 4 oxide or at the anode. So at the positive terminal or at the anode, sulfate ions react with lead to form lead sulfate, while hydrogen ions react with oxygen in the lead 4 oxide to form water. So at the same time, the hydrogen, so you can see the hydrogens are actually coming out of here. So the hydrogens are reacting with the lead 4 oxide. The oxygen react with hydrogen to form water, whereas the lead actually react with sulfate ions to form lead 4 oxide, to form actually the lead sulfate. So this is the reaction that takes place at the anode. At the cathode, so we've also seen that at the anode we have production of hydrogen ions reacting with oxygen to form water and lead 4 oxide. So water is formed at the anode, whereas at the cathode, that is now here where we have only the lead metal. So the lead metal reacts with the dissociated dilute sulfuric acid to form lead 4 oxide with hydrogen gas. So you can see here at the anode we have formation of hydrogen gas. Remember, hydrogen is positively charged, that is the hydrogen ions are positive, therefore they will always be attracted to the negative terminal. Remember, as we said earlier, that unlike charges will always attract each other. So at the anode, that is at the cathode, that is at the negative electrode, lead reacts with sulfuric acid, that is through this equation, lead reacts with sulfuric acid actually to form lead sulfate. This is what we are calling our lead sulfate, and hydrogen gas. So during this process, the electrons are amassed. The electrons are amassed at the negative plate, while the positive charges develop at the anode because of the deficiency of the electrons. So actually this generates electromotive force between the anode and the cathode because they are at different charges. One is highly positively charged while the other is highly negatively charged. So that creates a potential difference, or what we call an electromotive force, between the anode and the cathode. Now a single cell has an EMF of around 2.2 volts when fully charged, but this actually drops to around 2 volts when it is working. So as the battery continues working, lead sulfate, which is what we are calling the white deposit, the lead sulfate, which is the white deposit, forms on the plates, and the relative density of the electrolyte drops because of the formation of water. Remember, the water actually dilutes the sulfuric acid, therefore that's why its relative density decreases. So in recharging, a direct current is passed through the cell in the opposite direction to that of charging. So the process that takes place during discharging is reversed during what? Charging. So the important things to know here is that in a lead acid accumulator, lead 4 oxide is the anode used, or is the positive electrode, while lead metal is the cathode or the negative electrode, whereas the electrolyte here is the sulfuric acid. The electrolyte is the sulfuric acid. Now let's look at maintenance. How do we maintain accumulators? How do we maintain accumulators? Now we have 7 ways in which we can maintain accumulators. Maintaining means how to keep them safe, or how to reduce loss of what? Charges from the accumulator. So let's look at the 7 ways of maintaining accumulators. So the first way of maintaining accumulators is that the level of the electrolyte should be checked regularly and maintained above the plates. Then topping should be done by distilled water and not the acid. So acid can only be used in case where there has been spillage. So the first way to maintain an accumulator is to ensure that the level of the electrolyte is checked regularly and maintained above the plates. Now, how do we check that? Or if you realize the level of the water is has dropped below, the level of the electrolyte has dropped below, how do you regain that level? So we regain it by topping up. Now what is topping up? So topping up is the process of adding distilled water to regain the initial level of the electrolyte. The process of filling the electrolyte or filling the accumulator with distilled water to maintain the level of the acid. The process of filling the electrolyte with the distilled water to regain its initial level. So we are saying that topping up should be done by distilled water and not the acid. Why should we top up? Why should we do topping up using the distilled water and not the acid? So distilled water is used because, remember, distilled water does not have impurities. So we use distilled water because if we used impure water, those impurities will actually react with the acid. So we use distilled water because it lacks the impurities that will react with the acid. Then acid can only be used in cases where there has been spillage. That is where if the acid actually spilled. So we have said that topping up is just the process of adding distilled water to the accumulator to regain its acid level. Then we are saying that topping up should be done using distilled water because distilled water does not contain impurities that will react with the acid. So that is the first way of maintaining accumulators. That is by the level of the electrolyte should be checked regularly and maintained above the plate. That is by topping up. Then the second way of maintaining accumulators is that the accumulator should be charged when the EMF of the cell drops below 1.8 volts and when the relative density of the acid falls below 1.12. So remember, we said that a single cell should have 2.2 volts. While so if you realize that the level of the cell has actually dropped below 1.8 volts, you should recharge it. So the second way of maintaining accumulators is ensure that the accumulator should be recharged when the EMF of the cell drops below 1.8 volts and when the relative density of the acid falls below 1.12. Then the relative density of the acid is measured using a hydrometer. So we use an instrument called a hydrometer to measure the relative density of the acid. So we'll discuss that in another topic in Form 4, which is actually on applications about the topic flotation and sinking. That's where we look at the functions and the features of a hydrometer. So we are saying that the second way of maintaining accumulators is that the accumulator should be charged when the EMF of the cell drops below 1.8 volts and when the relative density of the acid falls below 1.12. Yeah, that way. Then we are saying that the relative density of the acid is measured using a hydrometer. Then the third way of maintaining an accumulator is that large currents should not be drawn from the battery for a long time. Large currents should not be drawn from the battery for a long time. Why? Because this weakens the lead 4 oxide and the lead in the mesh framework, causing them to fall off. So the plates then they buckle off. So the third way of maintaining accumulators is that large currents should not be drawn from the battery for a long time. And the reason is because if you draw current from the battery for a long time, that process weakens the lead 4 oxide, which was our anode, and the lead mesh, which was our cathode framework, causing them to fall off. So this causes the plates to actually buckle or even fall off. Then the fourth way of maintaining accumulators is that the accumulator should not be left in a discharged condition for a long time. So avoid leaving the accumulator in a discharged condition for a long time. Why is this bad? So the lead 2 sulfate deposits on the plates harden up and cannot be converted back to lead 2 oxide and lead. So this process is called sulfation. This is called sulfation. So we are saying that the accumulator should not be left in a discharged condition for a long period, because if it is left for a long period, the lead 2 sulfate deposit on the plates, they harden up and cannot be converted back to lead 2 oxide and lead. So this is called sulfation. So avoid leaving the accumulator in a discharged condition for a long time. The fifth way of maintaining accumulators is that shorting or overcharging the accumulator should be avoided. That is, shorting is allowing the plates to touch each other. So shorting or overcharging the accumulator should be avoided. Shorting or overcharging the accumulator should be avoided. That is our fifth way of maintaining accumulators. Then the sixth way of maintaining accumulators is that the terminals should always be kept clean and greased. The terminals should always be kept clean and greased. Remember, grease protects the terminals and also reduces some friction because it is a lubricant. So the sixth way of maintaining accumulators is that the terminals should always be kept clean and greased. Then the last way of maintaining accumulators is that the accumulator should not be directly placed on the ground during storage. Rather, it should be rested on some insulator like a wooden block. Why is that necessary? Because when it is stored directly on the ground, it actually earthing could take place. That is, electrons could flow to or from the battery, therefore discharging our accumulator. So it should be rested on some insulators such as a wooden block. So in summary, let me just state the 7 ways of maintaining accumulators. One is that the level of the electrolyte should be checked regularly and maintained above the plates. So this is achieved by topping up using distilled water. Then 2, the accumulator can be maintained by the accumulator should be charged when the EMF of the cell drops below 1.8 volts and when the relative density of the accumulator falls below 1.12. The third way of maintaining accumulators is that large currents should not be drawn from the battery for a long time. Why? Because this weakens the lead 4 oxide and the lead in the mesh framework, causing them to fall off and the plates even buckle off. So we are saying that the third way of maintaining accumulators is that large currents should not be drawn from the battery for a long time. The fourth way of maintaining accumulators is that the accumulator should not be left in a discharged condition for a long period. Then the fifth way, shorting or overcharging the accumulator should be avoided. The sixth way is that the terminals should always be kept clean and greased. Then the last way is that the accumulator should not be directly placed on the ground during storage. So those are the 7 ways of maintaining accumulators. Now we also look at capacity of a lead acid accumulator. The capacity of a lead acid accumulator. So what do we mean by the capacity of a lead acid accumulator? So the capacity of a lead acid accumulator is the amount of current that can be drawn in a given time from the battery. Simply the amount of current that can be drawn in a given time from the battery. So this is also the total amount of charge, that is Q is equals IT, and it is usually expressed in amperes hours. Then lead acid accumulators, they give a strong current over a long period of time as compared to other cells. So that is the advantage of one advantage of lead acid accumulators over other cells, is that they give strong current over a long period of time, and also because of an effective low internal resistance. So they have a low internal resistance, therefore they can supply current for a long time. Now the internal resistance of these cells is inversely proportional to the linear dimensions of the plates. That means the larger the dimensions of the plate, that is maybe the length and even the width, the larger the dimensions, the lesser the internal resistance. That is what we mean by inversely proportional. That is, if one quantity increases by a given amount, then the other one should decrease as a result of that initial quantity. So we look at an example involving the same. So example reads, a battery is rated at 30 amperes hour, 4 amperes hour, full stop. For how long will it work if it is steadily supplies a current of 3 amperes? So for how long? In this case they want time, so we just use the formula Q is equals to IT. That is, Q is the charge, then I is the total current, then T is the time in which that current is actually supplied. So if we want how long, it means we want time, therefore we make T the subject of the formula by dividing both sides by I. So we have I is equal, time is equals to charge over current, that is Q over I. Therefore if I substitute the values, we get that time will be equal to 30 amperes hours over 3 amperes. So the amperes and amperes cancels. 30 divided by 30 divided by 3, you actually get 10 hours. So remember, here we measure the time in hours. Example 2 reads, the charge stored by a cell A of plate dimension 0.2 meters by 0.2 meters, this multiplication, is 108,000 coulombs. Then A, we are asked to, what charge is stored by cell B of plate dimension 0.4 meters by 0.4 meters. So we've just said that the charge stored is usually directly proportional to the area of the plate. It's directly proportional to the area of the plate. So here we are just comparing. We just take the charge stored by cell A over charge stored by cell B should be equal to area of cell A divided by area of cell B. So we are comparing that way because the charge stored is directly proportional to the area of plates. That is, the larger the area of the plates, the more the charge stored. The smaller the area of the plates, the smaller the charge stored. So if I substitute the values, charge stored by cell A, so we are given the charge. We are told here that the charge stored by cell A of plate dimensions, this is this. So the charge stored by cell A is 108,000. So charge stored by A, I substitute with 108,000. Then charge stored by B, that is what they want us to find, is equals to the area of A. So area of A, we are given the length and width. So length times width gives us the area. So we have 0.2 times 0.2. So this gives us the area of A. Then also divided by the area of B. So we are told that what charge is stored by cell B of plate dimension 0.4 by 0.4. So if these are the dimensions, that is the length and width of cell B, then it means the area will be length times width. So here we have the length of B is actually 0.4, also the width is 0.4. So we just substitute 0.4 times 0.4. Then if I make charge stored by B the subject of the formula, I'll simply get 432,000 coulombs. We get 432,000 coulombs. So here you just cross multiply, so that this one will multiply by that, then 108,000 will multiply by 0.04. Then when you divide both sides by that, you simply get 432,000 coulombs. Then B, we are asked to, what is the ratio of internal resistance of cell A to that of cell B? So we say that internal resistance is inversely proportional to the length of the plates, meaning the larger the resistance, the smaller the plates. The smaller the plates, the larger the resistance. So if two quantities are inversely proportional, it means this is how we represent it. If it is A over B, then this other case will be B over A. But if it is directly proportional, it is A over B, then A over B, as we saw in the area. So area is directly proportional to the charge stored, but resistance is inversely proportional to the length of the plates. So we just compare, because they want a ratio. Remember, a ratio usually has no unit, so it's just a comparison between two quantities. So we take resistance of cell A divided by resistance of cell B should be equal to length of plate B divided by length of plate A. So they are inversely proportional. So length of plate B, we are told that B has a length of 0.4, so the length is 0.4. Then length of plate A was actually 0.2, so it is 0.4 divided by 0.2. If you multiply by 10 on the numerator and denominator, you will get here 4 divided by 2. 2 divided by 4 divided by 2, you get 2 over 1. So the ratio is simply 2 to 1. The ratio is 2 to 1. Lastly, we look at what we call an alkaline accumulator. Alkaline because the electrolyte used is actually an alkali, or simply basic in nature. It is a base. So we look at an alkaline accumulator. So in alkaline accumulator, the electrolyte in this case is simply an alkaline solution, hence the name alkaline accumulator. So that is, in this case, the alkaline we are talking of is the potassium hydroxide. Remember, potassium hydroxide is a base, therefore, and bases are always alkaline in nature. So the electrolyte in this case is an alkaline solution such as potassium hydroxide, which we are using here. Then the common types of alkaline accumulators are: one, we have the nickel, cadmium, and nickel ion accumulator. So here we look at the nickel ion accumulator. So nickel, in this case, the nickel hydroxide is our cathode, or the anode, or the positive terminal, whereas the ion is our negative terminal. Then so we are saying that the nickel accumulator with so the positive terminal, the most important thing to know here is that our positive terminal, or the anode, is simply the nickel hydroxide. The negative terminal, the cathode, is the ion. Then the electrolyte is our potassium hydroxide. Now, what are the advantages of an alkaline accumulator over a lead acid accumulator? What are the advantages or the merits of an alkaline accumulator over a lead acid accumulator? So an alkaline accumulator has 4 advantages over lead acid accumulator. One is that for an alkaline accumulator, large currents can be drawn from them. So large currents can be drawn from alkaline accumulators without destroying them, as opposed to lead acid accumulators. So the first advantage is that in alkaline accumulators, large currents can be drawn from them. The second advantage of alkaline accumulators over lead acid accumulator is that alkaline accumulators can be kept in a discharged condition for a very long time before the cells are ruined. So for alkaline accumulators, they can be kept in a discharged condition for a long time before the cells are ruined, or before the cells are destroyed. Unlike the lead acid accumulator, which actually its plates will buckle off if it is stored in a discharged condition for a long time. So the second advantage is that alkaline accumulators can be kept in a discharged condition for a long time before the cells are ruined. Then the third advantage of alkaline accumulators over lead acid accumulators is that alkaline accumulators, they require very little attention to maintain. Unlike the lead acid accumulator, we saw it actually had 7 maintenance. So lead acid accumulator is very difficult to maintain, but alkaline accumulators has they require very little attention to maintain. Then the last advantage of alkaline accumulator over lead acid accumulator is that alkaline accumulator, they are very light. They are light, or they are more portable than the lead acid accumulator. That is, for alkaline accumulators can be easily carried from one place to another. They are portable. So in summary, we've said the advantages of alkaline accumulators over lead acid accumulators are: 1, large currents can be drawn from them; 2, they can be kept in a discharged condition for a very long time before the cells are ruined; 3, they require very little attention to maintain; and lastly, they are lighter, into bracket, more portable than the lead acid accumulators. Now, what are the disadvantages of alkaline accumulators? What are the demerits, or the disadvantages of alkaline accumulators? So we have 2 disadvantages of alkaline accumulators. One is that they are very expensive. very expensive. 2 is that they have a low EMF per cell. They have a low EMF per cell. So alkaline accumulators are very expensive. That is, their cost is high as compared to lead acid accumulators. So they are very expensive. Then 2 is that they have a low EMF per cell. That is, the amount of electromotive force per cell or of each cell is actually low. So we have 2 advantages. 1 is that they are very expensive, and 2, they have a very low EMF per cell. Then lastly, we look at the uses of alkaline accumulators. Where do we use alkaline accumulators in real life situation? Alkaline accumulators are used in ships, hospitals, and buildings where a large current might be needed for emergency. So because they can supply current for a very long time, is that alkaline accumulators, they are very useful, or they are applied, they are used in ships, hospitals, and buildings where large currents might be needed for emergency, where large currents can be needed for emergency. So we've come to the end of our class today, but we need to discuss the quote of the day. So the quote of the day stated that if there was no darkness, no one will appreciate the importance of light. And also, failure is enough evidence that at least you are trying. So what does this quote mean? So the quote means that we should value challenges and tough times in life, because those tough times and challenges, they are the ones that make us grow our mental strength. So if you are faced with a challenge or a difficult moment, don't just lament and complain. Instead, focus on the lessons that you learned from that particular situation. And remember this, that no one is coming to change your life. You have to change it yourself. Every great person that you see in the world today was once a beginner and went through tough moments. Those tough moments are the ones that made them who they are. So never give up. Never give up. Tough times and challenges are part of the process to the success. If you want the results, you must be willing to go through the process. And the process to success is overcoming challenges. So have courage and never give up. Then do not allow your circumstances to define your destiny. Just because you are born in a poor family or in poverty does not mean that you have to die when you are poor. Yeah? Don't just say, because we didn't have this, I cannot become this. Do not allow your circumstances to define your destiny. And lastly, success will never lower its standards to accommodate you. Instead, it's you to raise your standards in order to achieve success. Thank you. We've come to the end of our class today. Actually, I'm very delighted. I'm very excited for having completed the Form 1 syllabus, that is for physics, actually book 1. It will not be possible without your support. So we meet in our next class. We'll be introducing Form 2 work. That is the very first topic of Form 2, which is actually magnetism, So this is the end of our Form 1 class. Thank you everyone. This is Kind Tuition Academy. Kindly hit that subscription button on YouTube. Thank you.